Thank you. All right. Hi. For the next couple sessions, we're calling these the showcase sessions. And this is Josh Lieberman. I've also been a member of the Standards Working Group and sort of started off in this exploration that we call GeoPose, uh, and participated particularly in this couple of the revelations that we had. Originally this was, well, there's GIS and there's graphic systems, and we need to sort of take GIS and add how things are pointing. Just let's add an angle in, and things kind of snowballed from there. And one of the snowballs was realizing that we're not just talking about position and orientation, we're talking about transformations. And one of the principal differences, that we're still getting our heads around is that a pose is not just, some geometry. It's a way to deal with the actual physical extent of a real or virtual entity, physical in the physical world, placed somewhere. And it might be geocentric, it might be local, it might be exocentric, it may be defined with regard to the solar system, but it's an actual space. And so we're trying to say something about that space, and we're trying to say about how that space relates to others that enclose it, that are related to it. And one sort of distinction I'd like to add to what Steve very well outlined in terms of what's GeoPose and what we can do with it is there are these sort of two fundamental things. One is, okay, relative to the sort of internal extent and okay, and so on of an entity, let's say a car, or let's say a person that over time may change their orientation, but still are within their sort of personal framework. But there's also this: how does it connect to something else? It can connect like the elbow to the shoulder. So there's the physical connections, and then there's the visual connections, which are a really fascinating part of this. And one thing we can do is to say there's poses and there's gazes. There's things that are there that are looking at, that have a visual connection to somewhere else. And what all of these possibilities do is make for both a really large universe of possible use cases and applications, and incredible importance to what are the details of those use cases and applications, because that defines what about the world we're really trying to express here, not only in 3 dimensions, but over time and functionally. And so it just kind of explodes. And the next 2 sessions are going to be very brief overviews of a number of these use cases and applications that have been developed. Some of them address interoperability, some of them develop different functionality, connections to different types of media, but I'll let you judge for yourself what this is interesting to. So we're focusing on, there's such a thing as a pose, position and orientation, but focus on what it is that's posing. And is it posing or is it also gazing? And in the context of what? Is it a local space? Is it a relative space? Is it geocentric? Because all of these things are possible within the framework of GeoPose. And the question is, how do we use it? And by saying how do we use it, we also define the future path to adoption and the evolution of this standard. And finally, what we're trying to get at is, what does GeoPose tell us about reality? I mean, we're covering both real and augmented worlds, but what we're really getting at with a GeoPose is physically where things are. And even if they're different, what space may they be sharing or adjoining or connected to? So really quickly, we have this is essentially this lightning talks of Katarina Ufnarowski, who's going to talk about augmented city work with VPS, visual positioning, as Steve mentioned. Rob Smith is going to talk about several 3 here and 1 later, use cases of using GeoPose for various kinds of tracking. And then, go back. There we go. Love these things. Steve is going to talk about solar poses, step into the universe here. And then, there we go. Okay. So Jan-Erik is going to talk about OpenVPS, Cesium Viewer, and OpenAR Consortium web app. Ali Hantala is going to talk about My Geoverse. Rob is going to return with a discussion of his Compass app. And then we're going to step a little further, and Mikel Salazar is going to start talking about reality markup language, where the implicit spaces, regions defined by GeoPose, are made explicit and connected to specific objects as part of their identity, and also a way to collect many different representations on the basis that they're describing the same space that the object occupies. So that's our next couple of sessions here, kind of put together. And so let's see, here we go. So I'm going to turn things over to Katerina on requesting and receiving geoposes and visual positioning.
Good morning, everyone. Do you hear me?
Yes, yes.
I'm pleased to be here, even if my session is online, and I hope to bring you a bit of sun from Italy, because still people can bath in the sea, and to present you our proprietary visual positioning system, made in Italy. I saw that online there is another person from Bari, so my personal greetings to him. Actually, we are a historical partner of OpenAir Cloud organization, and we were one of the first companies time ago to develop our small proprietary visual positioning system with a set of tools essential to work with augmented reality, and actually designed to empower and enable not only technicians, but also everyday users to work with it. And it was our goal, and still we are very proud to tell you that we achieved it, more or less. Then later I will maybe tell a few words about it. So 6 years ago, we introduced the first global point cloud, our first global cloud server, and localization services, as well as, of course, the set of tools. Can I ask you to move to another slide? Okay. So a set of tools, a scanner, an app that is available on both platforms, AC Scanner, quite user-friendly app offering different scanning modes depending on, let's say, user skill level. So there is a pro version for those who do it like professionally, and like for regular users, even for kids. Once app is installed, users simply follow the in-app guided procedure and choose the area to be mapped, and start to create own digital twins or own spaces. And then they upload everything using the same app to the server part or the server. Depends on the goal of the project. We offer 2 types of services, or customer can choose his own server, or we offer our hosting services. So we don't have any limits with it. Our scanner is quite good for indoor scanning, but it's quite very good for big spaces like squares, streets, regions, And using our monitor system, management system, you can actually see how is you placed your theory, your digital twin, and work with the content. So we have a part management system that combines server and client part. So we even give the possibility with the same credentials as you use for scanning to enter our management system and to work only with your digital twins. Of course, it's easy because you shouldn't see, maybe you don't want to see other projects or other series done by other users. So we also have a viewer. It's free for everybody. You can just download it or from Google Store or from App Store. But we also give possibility, like you will see then later, maybe during next sessions with our historical partners, like for example Ali Intal, that it's quite easy even to develop your own viewer and to use your own app to show what you created, let's say in this metaverse. So could you please move to the next slide? So just a few words about the peculiarity of our visual positioning system. We don't need to download anything on mobile phone. We do everything on the server part. So that's why we don't have limits for the size of point clouds. We have automatic point cloud merging. So you don't see the difference when you enter another cloud. You don't have any stop of session or whatever, or even interruption in some kind of visualization of the content. We have, if the connection is quite good, so if we talk about 5G or 6G, the localization is very fast. So we call it ultra fast localization, but well, right now I can say just that it's quite fast and it's quite enough to work without any interruption. We were one of the first who supported OGC GeoPose protocol and the second version as well. So we are really proud about it because we understand the importance of this step and we understand why and where we can go ahead with this standard to meet our goals, to keep our tools accessible for everybody. So please, next slide. Yeah, so using our tools and using our visual positioning systems, we managed to create in 230 cities in the world with different users of all ages, let's say, or with different users of different ages, different kind of installations or different kind of applications. So here you can see some of them. Well, it usually takes not too much time to scan and to create. In case of Bari, of course, it was a bit longer because we talk about 117 square kilometers of point cloud, where we placed 5,000 different objects. Thank you. And well, could you please start the video because I will save time in such a way, yeah. So you can see different kind of projects that we already developed. So this one is next to Colisée for a big event to promote in the world this event. This one is example actually in the US of the museum in the open air. Then you can see, well, just a second. You can see also quite interesting project done with school children. The next one, it's called St. Nicholas Flight, because in such a way, the St. Nicholas, in Bari, we have the Basilica of this famous Santa Claus that invites people to visit this church. And another one quite beautiful project that talks about advertising of jewelries that one company wanted to promote. These examples are quite few because, of course, we work a lot with industrial air, so we cannot maybe show a lot about industrial plants, but still we started even all these projects with localization and development of our visual positioning systems because we have been working a lot with autonomous vehicles. And that's why we wanted to offer the possibility to use visual positioning system not only for industry, but also for common users. Please, next slide. It's the last one, and actually it's not a very commercial use case. It's the case that shows that these topics, especially augmented reality, GeoPose protocol, localization, are extremely interesting for school kids. Working with school kids from 10 to 17 years, we not only proved that our set of tools is quite easy to use, but we also we also transferred the message how to use, how to touch a digital twin, how to be creative using it. Because actually, together with kids, we talk not only about technical part, but about storytelling part of all this metaverse world. And this year, we celebrated, we make some celebration because we actually had 3,000 students. Next year, or let's say this current school year, we are going to have more than 60 laboratories. So moving forward, our idea about GeoPose, about sustainability, about interoperability, and about creativity, because that is, at the end of the day, what is important for making our world better. So thank you very much. If you have questions, I'm ready to answer. And I'm sorry beforehand that I cannot participate maybe on coffee breaks and answer them personally. Thank you.
This is Rob Smith, use cases from Away Team. Rob, you there?
I certainly am. Hello, Josh.
Hi there.
Thank you. So just a couple of words of introduction. My name is Rob Smith from Away Team Software. I'm an invited expert in the spatiotemporal data on the web group, which is a joint committee between OGC and W3C for web standards. So at OGC, I'm involved with GeoPose and moving features. And at W3C, I'm leading development of web video map tracks, WebVMT, for synchronizing location with video for the web. And also with sensor data, which is important for GeoPose. I've studied several real-world use cases in the OGC testbeds over recent years, several years. And I'm just going to briefly explain how GeoPose has helped to address the issues we've encountered there. And these include LiDAR detection, visual tracking, and image cognition. So let's start with LiDAR tracking. Here we had an autonomous vehicle use case to track nearby objects. This was from testbed 17. And we used data from Ordnance Survey's street drone autonomous vehicle, which has 8 cameras and a LiDAR sensor on the roof. So the LiDAR is quite important to understand. It's similar to radar, for those who are unfamiliar. It has a sensor that rotates and emits a beam like a radar dish or a lighthouse, I suppose. And like radar, the sensor detects reflections of the beam. So it calculates the range of an object depending on the time difference of the echo. And each detection has a GeoPose because it has a location and an orientation plus range, which is beyond GeoPose. And what we were trying to do is to associate detections together in order to track objects because they are discrete. You get a ping, but you don't know whether that's the same object or not. And the first step in this was to classify detections as either moving or stationary. But the sensor data is in the vehicle's frame of reference and the vehicle is moving, which makes things tricky. It's an easy process for a human to do. We do it every time we drive. We can work out what's stationary and what's moving despite the fact that we're moving. But we used a GeoPose chain to transform those detections into world coordinates. And then, of course, it's easy to see what's moving and what isn't, because we can see whether 2 detections are at the same location or not. If they're at the same location, it's stationary. Otherwise, it's probably moving. So we could eliminate the stationary detections and use a simple predictor model to associate the moving detections into trajectories. And then we used the video to associate short segments into longer ones. Segmentation happens because of a number of reasons. Firstly, noisy data. Secondly, missing data because your view can be obscured by street furniture or passing vehicles. Things can get in front of each other. But using this fairly simple technique, we were able to successfully track the cyclist that you see in the picture here on the cycle path, and that's shown in blue on the map image underneath, from a moving vehicle, which is shown in orange. So you can see that particularly on the left-hand side of that image, the cycle path and the road don't follow the same track. So we are definitely tracking something else. More details of that can be found at the link shown here, which includes a short video, probably about 2 minutes, and a link to the engineering report. I'm not going to play that now because we need to move on, and there are several videos which you can watch at your leisure. Also, I don't want to be streaming it on a video call because it'll look terrible. So it's much better if you check this for yourself. So next slide, please. So the next use case that we're looking at is wrong-way traffic. So this is using roadside video footage to identify vehicles traveling against the traffic flow, which is an important public safety use case. We gathered video recorded by 2 smartphones on tripods at different locations. And the picture here shows one example of that. So the camera is at the left side of the map where the lines join. Camera has a GeoPose, and that's shown by the dark blue line that you can see on that map. And that corresponds to the frame center, which is shown by the crosshair in the video image above. The pale blue lines are the other sight lines, and each of those has a GeoPose as well. And all of these are in the camera's frame of reference, but they relate to detection zones, which are shown by the circles, which are in world coordinates. So these are locations on the road. And this allowed the footage to be geotagged as the vehicle passed by. And we're able to discriminate between lanes as well, even from this oblique view. And we can then use the, again, very simple technique, use the order that the detection zones fire in to determine whether the direction of the vehicle and whether that's traveling against or with the expected direction for that lane. So we can identify wrong way traffic. Unexpectedly, we were also able to detect U-turns, which just happened while we were filming. But yes, the detection zone fired in the order that indicated that the U-turn had happened. Again, more details shown at the link shown here, including, again, a couple of minutes of video presentation and a link to the engineering report. And finally, next slide, please. Image cognition. So this was in testbed 20. We looked at a video which has MISB data, so Motion Imagery Standards Board metadata, which was exported from the video to improve image cognition. As you can see, it's footage of a truck traveling along a highway. This is in the US, and it's filmed from a circling aircraft. So it's quite a complicated motion. And the data over time includes the frame center, which is the location of the crosshairs in the center of the video frame, which is just below the truck. Might be a little difficult to make out, but they are certainly there. There's various bits of telemetry you can see around the side of the video frame there. But this is focused on the truck, and that's shown in blue on the map underneath. And then we also have the sensor location tag, which is the location of the camera, which is shown in orange. So you can see moving in quite a different way. And these can be used to calculate the camera's GeoPose, which is what we're actually interested in here. And when combined with WebVMT, we can synchronize this with video to match the camera's perspective. So now every frame in the video has a corresponding GeoPose, which makes the complex interaction simple to understand. And when this is combined with photogrammetry data, so the map then has a visual representation, an aerial view or a satellite view, we can easily identify and locate any object we can see in the video with the corresponding object in the photogrammetry data, which is quite a powerful technique. And again, more details at the link shown, including again a video and a link to the engineering report. So, in summary, we've got three very different use cases here: LiDAR detection, visual tracking, and image cognition. In each case, GeoPose simplifies analysis and interpretation and allows data from different sources to be aggregated easily. Thank you very much. I think that's under my 15 minutes. Any questions?
Thank you, Rob, very much. Yeah, so please ask Rob questions on the chat. Take a look at the links that he's provided. We'll share those. Christine will tell you more about that. And I particularly love these examples because they show that how the number and diversity of GeoPoses exponentially increases the power and sort of interesting use cases that you can do. So one GeoPose is, it's a pose. Two GeoPoses, it's a sight to see, one looking at the other. 100 GeoPoses are a scene, right? 1,000 GeoPoses is a story. And so you start adding the GeoPoses in, the things that you can do with it are just become so much more interesting. And we'll look, I think, more show. Right now, Steve Smith is going to return to talk about keeping in the sun.
So this is back at the beginning, well, not the real beginning of developing GeoPose, but pretty early. And it, I think, is the original GeoPose implementation. It's probably one, it's the only, well,
10 minutes.
I won't even need 10 minutes because I'm lightning. So it illustrates samples that can be generated on demand. So I'll give you the URL. It's simple, geopose.io. So if you go to geopose.io, you'll get to a Swagger interface where you can get a sample of any form of GeoPose. So the 8 different kinds of GeoPose data objects that you can share. And you can also validate any GeoPose that you generate. You can either claim it to be a particular type and have it validated as that type, or you can present your data object, your hunk of JSON, and it will tell you what it thinks it was and whether it's in conformance with the standard GeoPose 1.0. So this is like application. It actually had a version number of 0.85. I changed it to 1 now. And you could say it's, how do I blind myself by staring at the sun? Which way do I look? Another wordy slide, but you can, the words mostly illustrate what I've just said. And following the link, then we end up on the Swagger interface. So I'll get a basic YPR GeoPose. So might be a little tiny, but in any event, what's in the middle here is the result that came back. It's a location and an orientation. And if we I'll put my glasses on now. Sorry. Aging, you'll all find out. So if I go to, I'll take validate any, which is the one where you just give it what you've got and it tells you what it thought it was. So I'm replacing string with what I got back. And it says, it's a valid advanced GeoPose, which it is. So geopose.io, you don't need anything else, and you'll get to this. It's a resource, and it's GeoPose implementation 0.
Thank you very much, Steve.